Hello everyone. Today we are going to go through Utopian Tree, which is a problem on the implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So here's the problem statement. Before reading the problem statement, if you're not yet subscribed to the channel, I really encourage you to subscribe to do not miss this set of video we are doing here related to data structure, algorithm, and competitive programming. So I won't read the problem statement line by line. I'll just see the situation. Here we have a tree which is growing through 2 cycles every year, and during the first cycle, the height of the tree is actually multiplied by 2, and then during the second cycle, the height of the swing is increased by 1. So we can have an example here. We are starting the tree is starting with a height of 1. After the first cycle, which is a cycle of multiplication, it will be multiplied by 2. 1 times 2, this is 2. Now is the second cycle. After the second cycle, it will be increased by 1. 2 plus 1, which is 3. After this cycle will be multiplied by 2. 2 times 3 times 2, which is 6, and so on and so on. Now, what we just described as approach is actually a pretty straightforward of what we can implement. So if you have someone a bit familiar with loops, you would directly think of looping through the cycle, and for each of the step of the cycle, if the cycle is actually even, depending on where you are starting. So if you are starting maybe at index 1, exactly like this, you will say, okay, if the cycle is odd, then we'll multiply by 2. If the cycle is even, then we'll increase by 1. So without wasting time, let us implement what we just described and see what it gives. So we are going to have something like this. We are going to have an answer that will start at 1 because the tree is starting at height 1. And then we are going to return our answer here. Now here we are going to loop from 1. This is our loop. Now I will just say that, okay, if the element is actually even, this is an even element. If the element is even, then we increase the height by 1 incrementation. And the else, what we are going to do is that we are going to multiply the element by 2. That is it. So let us submit this and see what it gives. You have a congratulations, everything is green. Perfect. Now, this is actually complexity big of n. If you're curious about how you can make it happen with just using complexity big of 1, you're on the right place at the right time. We are about to do it. So how will it look like? Let me just paste what I made up as explanation. So let us think of it as a binary, let's say in a binary context. We know that we are after each year we are going through 2 cycles, and the first cycle is the multiplication and the second one is adding. Now, what does that mean, multiplication in binary, in the binary context? Let us assume we have an element. Multiply the element by 2 is actually performing a shift. This is an example. Let's say we have an element 3. If you want to multiply 3 by 2, we need to convert the 3 into binary representation, which is 1 1. We need to perform a shift, which will basically add a 0 at the end, which will give you 1 1 0. And then if you convert this now into decimal, this will give you 6. So multiplying an element by 2 is the same as performing a shift. Now, adding 1 to an element is actually the same adding 1 as you just add 1. Maybe you have this 6, you convert in the binary, then you add the 1, it will give you this. If you convert, you have 7, which is actually 6 plus 1. So this is the process of adding. Now a here is actually a multiplication plus a adding. This is the spring plus the summer. Now how are we going to implement this? Now we can see that each year we are adding a 1 at the end. So we can see that, okay, from the number of the cycle, we can retrieve the number of the years. If you have the number of the years, we can construct a string consisting of the number of 1 corresponding of the year in that number of cycle, and from that we can retrieve the int value of that string, and that will be the result. So without wasting time, let us implement that approach and see what it gives. This is not correct. Okay, let us implement that approach and see what it gives. So I'm going to start by using the string constructor. This string constructor, I will call it S. That take as input 2 parameters. The first parameter is the number of occurrence the character should appear, and the second parameter is the character that should appear. So I'm starting 1. So I want to create a string constructor that will have 1, the number of year, and we can agree that if you have a cycle of 5, then we have 2 years plus 1 month. If you have a cycle of 4, we have 2 years and 0 month. So basically the number of months, the number of year is actually n divided by 2. Now, since we are starting with a 1, so the tree is always starting with a height 1. That is why we should add this one. Now we are here. We have a string containing the number of 1 representing the year in the number of cycle. Now we can move to, do we have a spare cycle after the number of year? To check that, we are going to say, okay, if the number of cycle modulo 2 is actually equal to 1, that means we have an odd number of cycle, then we have 1 spare cycle. Then we know that cycle will be represent a multiplication because it will be a spring. And what we said that is that a multiplication is actually a shift by 1, which is actually adding a 0 at the end. So we can say the S, we just add a 0 at the end of the S. So actually this string is perfectly the binary representation of our result. What we should do here now is to find out the int value of it. We can go through bit set. So we are going to have a bit set of a size of 60. I'm going to take 60 because I know the n can go up to 16. It's true that you can take less than that if you perform a label calculation to see exactly the size it will take, but we are sure that 60 will be more than enough. So we are creating a bit set of 16, which will be construct based on S. So I will call it ans. This is the variable, this is the input based on the string we just built. And here we can just return our ans, and this offer us this function that helps us to convert. So at this point we have everything up and running to have the result. Let us run and see what it gives. We have everything green. Let us submit. Okay, we have everything green. Now this is one approach of solving this. The interesting part of it is that it's big of 1. Now maybe if you want to go further, you can explore other opportunity or other way of solving this, still using the same approach. Let me just make another solution without using the bit set. I'm going to go with the same logic. I'm going to go like this. Okay, I'm going to take what I want to build. I will start by trying to build an int representing also the number of year, right? So I'm going to say R will take 1, the shift that we just perform here, the shift of n times n divided by 2 plus 1. So you need to wrap everything here because it will complain. Okay, we know that this is the number of 1. This is the number of 1 we need in our string. This is the same, or the same here. So if I'm performing this, it will give me 1 plus 0, 0, 0 number of time we need to have in our result. So this result, if I subtract this by 1, if I subtract 1 here, if I subtract this by 1, then what I will have will be, if I maybe this, if I subtract from 1, it will give me exactly. So this one, the previous one I just said, will give you 1 plus the number of 1 units, the number of 1 that appear corresponding to the year. Now if you remove -1, you have exactly the number of 1 unit, exactly. So this one will give you exactly the value of this one, this line here. So once you have this line here, what you can do is that, okay, now you need to check again the same condition that we did there. If n modulo 2 is actually equal to 1, since this is already an int, so you just say r times 2, and then here you just return your r equal to r times 2. So this is another way of approaching this without thinking of the bit set operator. You are just using int. You construct your int based on the shift. You perform the -1 to have exactly the number of 1, and then from that, if you have a spare month, if you have a spare cycle, you multiply by 2, and then you return the result. Let us run this and see what it gives. You have a congratulations. Let us submit. Everything green. And now the last one I'm going to show you is for those who say, hey, okay, yeah, we are able to do that. Why do we even need this if condition? Indeed, it is possible to have the solution without the if condition. Basically, the if condition is to perform a multiplication by 2, which is actually a shift. So you can just put the return here, right? And now you have to perform a shift on this. So you first wrap it. Now you have to perform a shift of 1 depending on this result. So if n modulo 2 is equal to 1, you perform a shift from 1. If n modulo 2 is equal to 0, you perform no shift, which is also a shift of 0. So if I put n modulo 2 here, you can replace this condition. So I don't need this, I don't need this. This is another approach of solving this. This is also another solution. Let us run and see what it gives. Everything green. Let us submit. Nice, perfect. This was my ways or my approaches of solving this. I hope you do enjoy it. Feel free to leave me a thumb up if you like the video. Don't forget to subscribe, share, and I will be really happy to have your comment to exchange with you related to this. See you on the next video. Ciao.